seconds. Definitely not what we'd like to see when most interactions seem to complete in less than 100 milliseconds. Of course, there's multiple potential causes to explain this difference: network latency, performance differences across devices, or back-end service issues. To help identify where latency is actually coming from, we can look to our service diagram. I can see I started my search at the iOS client, and Lightstep has built out all of the resources I'm dependent on, even those at the bottom of my stack, 6 layers downstream from my iOS client. Looking at the latency distribution depicted by the yellow rings around each service, I can see that the bulk of the transaction time is spent on the iOS client, waiting as the response traverses the internet from our backend to the user's device. It's worth noting that even though the API proxy is waiting on a response from the API server, Lightstep doesn't depict that latency since it isn't on the critical path for the transaction. This ability, powered by the underlying trace data, means I don't have to waste time looking into parts of the system which aren't causing meaningful impact. Essentially, if you make improvements where you can see yellow rings, you're sure to have a meaningful impact on the critical path. But today, I'm not looking to improve overall performance, I'm searching for regressions. And to accomplish that, I want to see how this changes between my total